Hello, hello. The topic of today's lesson is angles inside isosceles triangles. We are still looking at triangles. They have many special relationships depending on type of triangle it is. And today we're going to look at special isosceles triangles. Now, what is so special about isosceles triangles? My friends, we're in grade 5. I hope you remember that in isosceles triangles, 2 out of 3 sides are equal. And we mark them with dashes. When we have 2 equal sides, we mark them with dashes. So which sides are equal in this case? Based on this dashes, side AB is the same length as side SC, or we can say in language geometry, congruent. These 2 sides are congruent. Now, if we are to perform a very, very basic exercise, and if we are to fold this isosceles triangle along the altitude, along the central line, right? This is called altitude. Sometimes we call it height. If we are to fold it and line up angles B and C, we realize that angle B equals to angle C. Therefore, the angles in isosceles triangles, the angles opposite the equal sides are equal. The angles opposite the equal sides are equal, meaning angle B is the same as angle C. Many geometry problems come up from this simple theorem. So in a triangle XYZ, let's consider triangle XYZ. Remember, we read it from X to Y to Z. We have 2 angles measuring 54 degrees. Which sides are equal? Is this triangle isosceles? Yes, this triangle is isosceles. We can say that XY equals to ZY, right? We can, of course, fold this triangle along the dotted line, but you don't have to. We learned that XY equals ZY if 2 angles are equal. So it is an isosceles triangle. Yes, it is. Now let's perform exercise 12. What is being asked? They're asking us which of the following triangles are isosceles. Well, let's see. What do we have? What do we have? We have angle that measures 38 degrees, and angle that measures 27 degrees. Well, just to check on a third angle, let's go. We have 180 minus 38 and minus 27. Does that give us anything? Let's just say it like that, right? 38 plus 27 is 65. And of course, when we do 180 minus 65, we get some obtuse angle. No angles are the same. All sides are different. It's a generic triangle scaling. We can mark them 1 dash, 2 dashes, 3 dashes, meaning not a single side is the same. No, this is not an isosceles triangle. Let's take a look at triangle B. Of course, we have an angle of 30 degrees and another angle of 30 degrees, giving us an understanding that these 2 sides must be equal to each other. We label equal sides with dashes of equal number, single dashes. And yes, triangle B is isosceles. 2 sides are equal. Now we have a triangle C. Okay, my friends, we have a 75-degree angle and a 30-degree angle. Okay, no angles are the same, but let's, to be sure, find the third angle. Let's go. Let's use the theorem that we know all angles in a triangle add up to 180 degrees. So let's go ahead, add up subtract 75 and 30 degrees. And what do we have? 180 minus 105. And we have the final third missing angle of 75 degrees. And look, what do we have? We have 2 angles that are the same measurement, therefore the 2 sides opposite of these angles are of equal measurement. We can label them with the same number of dashes. And yes, triangle C is equal isosceles. I hope you found this useful. Next topic is equilateral triangles and their angles.